Hey everyone, welcome back to my channel. In today's video, I'm showing you version 2 of my smart door lock system built with the Raspberry Pi. In this version, I've added something really powerful. Whenever someone tries to unlock the door, it triggers AWS Lambda Function that automatically sends an email notification to the users. That means you'll instantly know when and who tried to access your door all in real time. I'll walk you through the entire setup from the hardware connection to the AWS integration, and then we'll test it live. Let's get started. Now I'm going to show you the project workflow. First, we have the brains of this project, which is the Raspberry Pi 3B Plus. Then we have two inputs, RFID and keypad. Once the correct pin or tag is given to the RFID and keypad, then the green LED will glow and servo will move according to the lock state or unlock state, and the red LED will glow only when the wrong pin or wrong card or tag is given to RFID. Then a status message will be sent to the AWS IoT core, which will tell which status we're triggering right now. Then once we do that, the AWS IoT core will trigger the Lambda function telling this is the status that the AWS IoT core has received. Once the AWS Lambda function has been triggered, then the correct email will be sent out to the owner of the door lock system. With the circuit, and there are two main components, this RFID module and this keypad module. When you put the correct pin on the keypad, then this green LED will glow and the server will be at 90 degrees. That means it's unlocked state. And once we put the wrong pin on this, then this red LED will glow and the server will not move. And if you put the correct pin the second time, you know what happens? This green LED will glow once more and the server will be at 0. That means it's locked position. And same thing for this RFID. If you put the card or tag correctly the first time, this green LED will glow to indicate that it's the correct card or tag. Then the server will be in the unlock state, which is 90 degrees. And the second time you place a card or tag, this green LED will glow once more, and the server will be at 0 degrees. That means locked state. Then this red LED will glow only when the wrong card or tag is placed on this RFID module. Now I've programmed the Raspberry Pi so that the red LED, green LED, RFID module, keypad, and the servo can start working with the AWS IoT card, then the Lambda function, then the email. So I've imported few libraries, the RPI GPL library, the time library, the MQTT library, the SSL library, JSON library, underscore thread library, and MFRC522 library, which is for the RFID module. Then I set up the pins 13, 19, 18. These are for the red and green LEDs. Then 12, 26, 24, 23, 21, 20, and 16 are pins for the keypad. Then I've started the RFID module with this simple MFRC522, which is the RFID modules library, and I've started up. Then we have started the MQTT so that once this program starts running and we use one of the verified methods, the RFID or keypad, the AWS will get a message saying this is the status. Then it'll trigger the Lambda function. So we have few helper functions, which is the publish status function, flash LED, move servo, and door unlock and door lock functions. These are some of the helper functions that do these functions. The publish underscore status function is for giving the status to the AWS IoT core so that the Lambda function then can be triggered. Then flash LED tells which LED to flash depending on the correct pin or tag or wrong card or wrong pin. Then move servo tells which way we need to move it, 90 degrees for unlocking or 0 for locking it. Then it tells door unlock and door lock. These ones tell whether the door has been locked or been unlocked. And then finally, we have two last functions, which is reset passcode tells that the pin that we have put in the keypad has to be reset. Then check keypad. This function is telling whether we have entered the passcode correctly or wrong. And depends on that, it'll tell which LED to flash and then it will reset the pin so that we can put it once more. Then we have two functions last. The RFID, which is meant for the RFID module, so that once a card or tag is placed on it, then it'll tell, oh, this is the LED we need to go, and this is the direction we need to move the servo. And the AWS IoT core will get a status telling this is the status we want to send to the Lambda function. Then it will tell the email, oh, this is the subject. then this is what we want to get the message for because of the status. Then finally, we have a try, except, and final functions, which are meant for finishing the code smoothly, neatly, and making the GPS cleanup successfully. Let's create the AWS IoT Core by going to all devices, then things, then create thing, then single thing. I'm going to create now many things, which is going to be single thing. Then name it as Raspberry Pi 3B4. Then I'm going to auto generate new certificate, which is recommended. Then I'm going to create a policy. I'm going to create a new policy, which is going to be Raspberry Pi door lock system. Then I'm going to allow on policy effect and allow everything on policy action and everything on policy resource also. But we need to lock it down if we're going to give it to different people in the world. Once I've created the policy, I'm going to go back to the create single thing. Then I'm going to click on the one that we just created, the policy that we just created, and press create thing. Then it will tell us to download few certificates. The only certificates we need is the public, private, and the root CA certificate. Once I'm done, I'm going to press done. And that's it. We have created our AWS IoT Core. Now that the AWS IoT Core has been successfully created, we need to make a rule and connect that with the Lambda function. So I'm going to get started by going to message routing, then rules, then create rule, and I'm going to name it as door lock alert rules number 3. Then press next, and we want SQL version as 2016-03-23. Then we want the SQL statement. It's going to differ between the different AWS IoT cores that you guys have set up. So we're going to press next. Then we're going to press on action, and then we're going to do Lambda function. Once we do that, we need to create a Lambda function so that we can use it with this rule. So I'm going to create a Lambda function and name it as notifier number 3. Then it's going to ask us runtime. We want Python 3.13, which is right here. And we want architecture x86_64. And then we're going to create Lambda function. Now that the Lambda function has created successfully, I'm going back to the rules and choose the Lambda function that we just created. By refreshing, then it will show up here. This is the Lambda function we want, and we want latest. And we're going to press next. It's going to show us these are the steps that we just did. Is it correct or not? And we can edit it right here using these buttons, but it's correct for me, so I'm going to press create. Now that we have successfully created the rules, now I'm going to show you how to configure the Lambda function. Now that the AWS IoT Core, the rules, and the Lambda function has been successfully created, we need to configure it before we can start making the SNS and program the Lambda function. So if you go to configuration, then go to role name, and it's going to differ between different Lambda functions that you guys have created. I'm going to add a permission, which is going to be attach policy, and which policy you may be asking. It's going to be the SNS, and it's going to be the full access one so that the Lambda function can use the SNS properly so that the emails can come to us properly. Once we have created it, I'm going back to the AWS Lambda function, then adding a trigger. What trigger you may be asking? It's going to be the IoT one because that's the one that we're using, and we're going to be using a custom IoT rule, and it's going to be a new rule. Which rule? The one we just created. It's going to be an existing one actually, and it's going to be the one we just created, which is going to be door lock alert rule 3, and we're going to press add. Once we have done that, we have configured the Lambda function. Now we just need to make the SNS, and then we can start programming the Lambda function. Now we need to create the SNS so that the emails can come through from the Lambda function. To get started, we need to make a topic so that the email can subscribe to. So I'm going to create a brand new topic, and it's going to be a standard topic. Then my topic name is going to be Studio Door Alert number 3. Then I'm going to press create topic. Now we have made the topic we need to subscribe to using an email. So we need to provide an email that can be subscribed to this topic, which I'm creating now. I'm going to give protocol as email, then the email that I want. Then I'm going to press create subscription. And then we have successfully created the SNS and the topic and the email that can subscribe to this topic. Now we only need to subscribe to the topic. Then we need to make the Lambda function. I can show you the demo. Now that everything has been set up successfully, we need to make the Lambda function code. I pasted here with the two libraries to start it off. JSON library, and Budo3 library, which I've set up here. Then we have the topic ARN, which we got from the SNS topic that we just made earlier in this video. Then we have messages. We have different types of messages depending on which status the AWS IoT Core sends with the correct icon. Then we have two functions. One is to send SNS message, which means which topic we have subscribed to, that topic we're going to give to this Lambda function. Then the subject of the email, and finally which message. Then Lambda handler is just a function that knows which status that the AWS IoT Core has sent to this Lambda function and tells it send SNS message, oh, this is the status we need to send. And finally, we have message sent successfully. That means depending on if this messages, one of these messages have been sent to the email or unknown event has been sent successfully through the email. Now that we have set up the AWS IoT Core, the Lambda function, the SNS, and the rules, and programmed the Lambda function and the Raspberry Pi so that the RFID, servo, green LED, red LED, and keyback can start working, I'm going to show you the demo. So in this AWS IoT Core, we'll get a status as soon as I put this RFID tag for the very first time, which is going to be unlocked, and this green LED did glow and the servo did move, and I'm going to get a notification from the AWS right now because the Lambda function has been triggered, which is going to be door unlocked using a valid RFID tag. If I go back to the AWS IoT Core and put this RFID tag, the green LED did glow, but it's in the unlocked state because I didn't do it within the 10 seconds. Now if I do it once more, this green LED did glow and the servo did move to 0, which means that it's in the locked state, and I did get a new notification from AWS IoT Core, which is door unlocked using a valid RFID tag. Then if I use the keypad, I'll get different notifications, like the correct pin I'm putting right now, green LED, it's going to unlock state, and I'll get a new notification in a second, which is door unlocked using correct pin. But if I put the wrong pin by accident, it's going to be red LED and nothing happens to the servo, and I'll get a new notification right now in 1 second. I got the new notification, which is alert. Someone tried a wrong pin. That means by accident I did it. So now I'm going to put the correct locked pin. When I do that, the servo moved to 0 and this green LED did glow, and I'll get a new notification, which I did. Door locked using the correct pin. And that's it. Our smart door lock system version 2 is now smarter than ever. With AWS Lambda integration and automatic email alerts, you'll got a real-time IoT security system that keeps you in for 24/7. In version 3, I'm planning to take this even further, adding a camera with AI face detection to recognize valid users before unlocking the door. So make sure to subscribe, hit the bell icon, and drop a comment below if you got cool ideas for version 3. Thank you for watching, and I'll see you in the next project.